Hey, welcome to Chemistry with Miss E. Here we are with average atomic mass calculations. Hopefully at this point you have learned what an isotope is. If not, pause real quick, go watch my isotope video, and then come back to this one. However, if we're going to continue and moving along, we do have three isotopes here, okay? I've got 12,6 carbon, 13,6 carbon, and 14,6 carbon. Notice that they all have sixes at the bottom. That is an atomic number, which is the number of protons of carbon. If we have 6 protons, then it has to be carbon, so that checks out. But what's changing between these three isotopes? You can see the top number is changing, right? We're going from 12 to 13 to 14. That's the number of neutrons, which is changing, which is the definition of an isotope, okay? So carbon in this format has a mass of 12. This isotope of carbon has a mass of 13, and this carbon has a mass of 14. I have a question here, just as conceptually speaking. You will have a question like this when it comes to isotopes. Which one of these would be the most abundant? And also, which of these would be the most stable, right? So how do you figure that out, okay? You need to know that the periodic table, okay, the mass that is listed for each of these elements on the periodic table is the mass of the most abundant and the most stable isotope that exists for this element on planet Earth, okay? So the periodic table has already done the work for you and giving you that information. You just need to be able to connect the dots. So if I'm trying to figure out which isotope of carbon is the most abundant and therefore the most stable, then it would be whatever the mass closely represents on the periodic table. Carbon on the periodic table has a mass of 12.01, so that means carbon 12.6 is going to be the answer for both of these. And this rings true for all the elements, okay? So on planet Earth, the isotope that is the most abundant is the isotope that is most stable, and that's going to be the one that you're going to find as the mass on the periodic table. Let's go ahead and continue on, though, and let's get into some calculations because you will be seeing some word problems when it comes to these things. Number 1, europium consists of two isotopes with a mass of 151 and 153. Europium 151 has a percent abundance of 48.03%, whereas 153 europium has a percent abundance of 51.97%. Therefore, what's the average atomic mass of europium? You could go and just get the mass from the periodic table, but your teacher is not going to accept that answer because you're not showing any work whatsoever to get to that point. But it is a good way to check your work at the end, and I'll come back to that once we finish our calculations. The formula to solve for average atomic mass using isotopes and percent abundance is the same for every single question. You're going to take the mass of each isotope, so 151, and you're going to multiply it by the decimal form of its percent abundance. What I mean by that is europium 151 has a percent abundance of 48.03. I need to divide that by 100 because percents are out of 100. And after doing that, I get 0.4803, right? If you're doing mental math, you could also move your decimal two numbers to the left, whatever works for you. Don't let simple calculations, though, be the reason you get an answer wrong. Work with it, practice it, make sure you're comfortable with it. 48.03 divided by 100, again, 0.4803. So I'm going to multiply those two together. And then you're going to do this process for however many isotopes exist in the word problem that they gave you. This word problem gives us two isotopes, so I know I need to do this one more time, and I'm going to be adding them together. Because what I'm saying is this isotope makes up this much of europium, and the other isotope makes up that much of europium. And so when you put the two together, then you're going to get what europium actually is on planet Earth, in nature, and on the periodic table. So the other mass of europium is 153. Multiplying it by its decimal form of the percent abundance. Again, move the decimal 2 to the left or divide by 100 in your calculator to get it out of the percent, and that is 0.5197, okay? So there you go. Now I'm going to do these individually in the calculator, then I'm going to add them together. So I'm going to do 151 times 0.4, oh well, it was right up there, times 0.4803, and then I'm going to do the same thing, 153 times 0.5197. Now I'm going to take those two answers and add them together, and I get 152.04. I'm going to round it to the hundredth place, 152.04. AMU would be the unit for atomic mass unit, and again, you should go check your work, okay? What I mean by that is I should go to the periodic table, and if I find europium, right, I get 151.96. I got 152.04. That's very, very close, and it should be very close, if not almost exact. When you're doing these calculations, okay? So that's your first example, all right, for number 1. Number 2, Strontium consists of 4 isotopes with masses of 84, 86, 87, and 88. In parentheses here, they give us the percent abundance of each of those isotopes and calculate the average atomic mass, okay? So again, same formula. Take the mass, multiply it by the decimal form of the percent, add them all together, and you get your average atomic mass. So we're going to do 84 times, right? Again, I would move this 2 to the left, so 1, 2, so it's 0.005, all right? And then I'm going to, those would be together, plus I have another isotope, a mass of 86, times the 9.912, so 0.099. Again, you could be plugging these in the calculator, dividing them by 100. 87, this would be 1, 2, so 0.07. And we've got one more, don't forget about it. We got 88 times its percent abundance, 82.06, that is 0.826, okay? Make sure you keep all of the decimals that they give you, okay? Don't chop off a number randomly. So in other words, 0.826, okay? Use all of the numbers that they give you. We're going to go ahead and multiply these in the calculator. And after doing so, I believe, actually just for ease for ease of time, I have the answer here. And we're going to have, let's see, yeah, we should get 88 atomic mass unit after doing all of that. And there we go. So, all right, so that is our 88 AMU. Sorry, lost the screen for a second. Now we're back. Okay, so that is number 2. And again, if you go and look at strontium on the periodic table, strontium has a mass of 87.6. Again, 88, very close to that, okay? All right, last but not least, let's do one more here. Hydrogen is 99% 1H, 0.8% 2H, and 0.2% 3H. So calculate the average atomic mass of hydrogen, okay? So here we need to first understand that these are still isotope notation, okay? And that top number that they gave us in each of these isotope forms are the mass of those isotopes, okay? So for one hydrogen, that's going to be a 1 times 0.99. All right, that's a big percentage that isotope is making up for hydrogen. And that makes sense because hydrogen on the periodic table does have a mass of 1. We have 2 for the mass and times that decimal, so 1, 2, so 0.08. And then plus, we have 3 as the other mass and times 0.02. 0.002. Did I do that right here for the 0.08? 1, 2, no, I need another 0. 0.008, there we go. Awesome. Okay, good catch. All right, so then now we're going to add these together. So 0.99 times 1, that's obviously going to be 0.99. 0.008 times 2, that's going to give me 0.016. And 0.002 times 3 is going to give me 0.006. I add those together, and I get 1.012. And that would be my answer, AMU. Again, that should match very close to the mass on the periodic table, and it is pretty close. 1.008 is the periodic table mass. We calculated 1.012, so very close. That's a good thing. And there you go. That is calculating average atomic mass when given isotopes and percent abundance. See you on the next one.